Hey friends, we are now working in lesson 1.4 and 1.5. Now 1.5 has a very short section that we're going to bring in to 1.4, so please bear with me. This is a longer notes. So it might take up to 2 days, or it might take up 1 day, just matters how much time we have in class. So let's go ahead and get started on this. Well, the first thing we need to remember is that when we have a line, and we know that a line goes on forever. Well, go back to Algebra 1. In fact, you see this in my room. I have a number line with integers on it that represents our real world numbers, okay? And the cool thing is we put nice little location marks, so if I put a point on a line, I can locate where it is. That's called its coordinate. So 3 is the coordinate of point C. It gives it value. Why is that so important? So I can figure out how far apart they are. So I want to look to see what's the distance between point A and point C. Well, remember when you're a kid, you'd sit there and you'd start at A and you'd go 1, 2, 3, 4, 5. Right? So it's 5. They're 5 apart. And we also know that distance is always positive. And we kind of base that off of what we learned with our Ferris Bueller's video the other day about his friend. But now we have to be able to also be able to do this mathematically. And since we know distance is always positive, we do it mathematically by just taking the absolute value of the difference of the 2 points. And really, it's pretty simple. I can go 3 minus a negative 2. So 3 minus negative 2 makes that absolute value of 3 plus 2. That equals 5. So I know that's still the distance of 5 apart. Or I can do the same thing, go negative 2 minus 3, that gives me the absolute value of a negative 5. It's still 5. So I could either count or I could actually calculate. I want you to be able to calculate. You're going to have to show me work when it seems that simple, of being able to do the distance between the two. Now the fact that we can find the distance between the two is called the ruler postulate. Now, look at what it says. The distance between 2 points A and B can be found by the formula of the absolute value of their coordinates, the difference of their coordinates. We find the length of a line segment. So remember, line segments are finite. We can measure them, which is very good. So we have to make sure that we use correct notation when we're talking about physical length. Now remember, when I have a line, let's go AB here, I name it line AB. If I want to start and stop, I have to go my line segment. So it'd be line segment AB. But if I want to know how far apart these two are, like in this case, I want to know that it's 5, I have to take the bar off. The bar, this is to name it, this is to describe it. So the bar put away lets me know that that's red, the length of segment AB. So here we're going to put our notation in. The bar goes away. Now this is what it means, the length of it. What's the distance between those 2 points? So the instant I take the bar off, I'm now physically been able to do algebra with it. I can physically put an attribute besides saying, hey, that's what you are, you're a line segment. Now I can describe its length. Think of it kind of like this. This would be like saying, that's Mrs. G. Everyone knows who I am. Well, they will know if they don't know, right? You know that I'm a person, I'm a math teacher, great. This is like saying, Mrs. G's weight. And no, I'm not telling you my weight. But this describes me. This is who I am, but this describes some trait about me. So that's the difference. And remember that here, the segment bar means line segment. AB. There's just a difference in notation. We will work really hard to do this. Now, I want to show you something that's very common sense. Now, remember, postulates are just, duh, these make sense. Well, obviously, because they are rules that can't be proven, but they are always true. Remember that. It's like we said God exists. It's the same type of idea. So when I'm working on this, this is called the segment addition postulate. Now, this has a name. You should be able to tell me what it means in your own words. I'm adding what? Addition, segment. I'm adding segments. No big deal, right? We can definitely do that. Well, here's what we're showing here in the diagram. Here I have a line segment AC, but I have another point in between. That's called betweenness. So to be between, you have to be between the two endpoints, somewhere in there. And I know that point makes two smaller ones. I have segment AB and I have segment BC. Now, do you guys agree with me that the two smaller ones make the bigger one? Someone's going, can you not be more logical? Exactly. And really, it's this saying, sum of the parts equal the whole. Sum of the parts equal the whole. And this is describing those parts. So I know I go segment AB plus segment BC equals segment AC. Well, if that's 3, let's say this one's 5. That's their lengths. No, that's not coordinates, lengths. I just go 3 plus 5, which equals what? 8. So notice my notation now. That means the length of segment AC is 8. But notice the instant I put that equal sign, there is no bar over the top because I'm describing the length of a line segment. So pretty cool. Segment addition postulate just says, hey, I can find the length of a line segment. So it's the sum of the parts equals the whole.